Hello everybody, and thank you for the introduction, Margot, and thanks for everybody joining us on the call today. We have a lot of information to get through. I hope to keep it interesting, and hopefully it will raise a few questions and you'll want to follow up and talk to us afterwards. So the scope of what I'm going to talk about today is basically we've observed with our interactions with our customers that orders of magnitude in file size reduction can be achieved for large CAD assemblies of plant equipment when people are trying to integrate it into their design systems. So we've observed that these kind of simplifications are possible. What I'm going to try and do today is demonstrate how we can use our CAD fix technology to do that simplification, primarily in an automatic mode if we can, to save even more time, to give you more manageable pieces of equipment that you can integrate with your plant system. And then hopefully through viewing the webinar you'll understand or see how you can save days or weeks of non-productive geometry handling that increases your efficiency and helps you get to market, get to commissioning the plants faster. That's a general scope of what we're going to talk about. The agenda is quite straightforward, a few things. I'll just spend 5 minutes talking about the need for simplification, although I'm assuming that most of you on the line are going to already understand that requirement, but we'll just refresh some of the requirements and the needs. We'll look at the benefits that can be achieved when you can get a big simplification of these equipment models. I'll highlight some of the functionality in the CAD fix solution that we've applied to simplifying large CAD assemblies, and then give you a live demonstration just to hit on some of the key points of functionality and how they can be applied to your models. And then to put it even more in context, we've got a few case studies at the end. The models are too big to run live, but I've got some images before and after of how we've applied the simplification process to good effect. And then all being well, we'll have a few minutes at the end for some questions and answers. So to begin with, the need to simplify. Why do we need to simplify large CAD models before integration into plant design systems? Well, the plant on the layout will incorporate a very large number of machines, of pieces of equipment. Now, those pieces of equipment are normally modelled and supplied by an equipment supplier. They're probably modelled in a mechanical CAD system like CATIA or NX, or SolidWorks or AutoCAD. And they're modelled as full mechanical CAD parts, so they're very detailed, and they generally contain a lot more detail than is needed for integration in the full plant layout. If we can quickly identify the small parts that aren't needed in the plant design, or quickly identify how to simplify those parts that we're keeping so they're much more manageable size, then it allows for a seamless integration of the equipment models into the plant layout. There's also issues with users in the field, service engineers, support engineers, commissioning engineers that often receive the data on their tablet or over a cellular mobile connection. Aside from the physics of the mobile connections, they've also got the large file sizes that are very slow to download and quite expensive as well. So there's clearly a need for simplification on their part. And actually on the originator of the equipment, the person sending the data, they may have intellectual property issues where they don't want to supply the whole model. They just want to give you an outer envelope or a spatial domain so that they protect their IP and their investment in their design. Now if we try and look at that schematically, you've got the data sender. Now in this case he's sending out a large equipment assembly on a skid. It's a 798 megabyte fully featured mechanical CAD model, and it's gone out to an engineer in the field. It's gone out to a systems designer, a plant systems designer, a change control engineer, support engineer. Now each of those have got issues. The data sender is worried about the IP in the model that he's sending out. He may want to protect it. The receivers downstream, so the plant design system, straight away they see the size of the file and they know it's going to slow down their plant design system. somebody else is looking at it and says, I don't need this level of detail. I just need the key points, the tie points, so that I can position it in my plant. Maybe I'll recreate it myself because it would be much easier. We've also seen lots of cases where people are saying it's just no good. I've tried to import this model half a dozen times and it's not coming in. The system's failing, it's hanging, I don't get the whole model in. What can I do next? And then the guy in the field, he sees the file, he sees the download speed and the progress bar just starting, and he says, this is going to take forever. I can't download an 800 megabyte equipment assembly. Oh, and just by the way, it's another CAD format I've got to deal with. These are kind of the issues that you're faced with as you transmit these large equipment models around the environment. It's probably a good time for a question, Margot.
Yeah, let's do our first poll. I think that you all can probably identify with some of the pain you see here. Let's talk about which plant and layout system you might be using. So we've listed some of the top ones here: Autodesk's AutoCAD Plant 3D, Intergraph's Smart Plant 3D or CADWorks. We've got Aveva, CADISON. Also, you might be using Bentley or Technomatix. That kind of fell into the other category here. So if you could ring in quickly, and then we will share the results with everyone. Give you just a few more seconds to vote. Okay. All right, I'm going to close the poll, and then we're going to share these results. So it looks like 70% of the people online are either using Bentley, Technomatix, or another brand. 30% for Autodesk, 30% for Intergraph, 17% Aveva, and 4% CADISON. Okay, I'm going to hide the results. Thanks, guys, for participating. Back to you, Andy.
Okay, thanks, Margot. Quite interesting, quite a spread. Be interesting to see when we've looked at the simplification that can be achieved, whether everybody agrees that this could help with getting data into all of those systems. So let's look at the potential for simplification that is available. This is just one single equipment assembly. It's a tumbler, a mixer, or a drying unit. The original mechanical CAD assembly arrived on the plant designer's desk as a 40 megabyte DWG file with 73,000 CAD faces defined in that file. Here's the simplified model. It looks exactly the same. Okay, some of the details not there, but the outer envelope, the key tie-in points are the same. It looks like the same piece of equipment. But the CAD file is now a 1 megabyte DWG file with 2,000 CAD faces. So we went from 40 meg to 1 meg. We achieved a 97% data reduction with something like a 15-minute runtime, which is quite a big achievement. If we look at that in terms of the entire plant, we could take that 97% data reduction and apply it to all of the equipment in that plant. So we're now talking about applying that kind of data reduction to hundreds, potentially thousands of small pieces of equipment and small parts, deleting thousands of parts that are not needed, automatically simplifying parts you want to keep. But if we extrapolate it from just one equipment assembly to the entire plant, then we're looking at saving potentially gigabytes of data that have to be moved around the system, imported and exported into different systems, and possibly hours of integration time versus days or weeks trying to play around with the big models. And if we now go back to our schematic and look at the sender now is called a CADFix sender because he's using CADFix to simplify the model. Instead of an 800 megabyte fully featured mechanical CAD model, he's now translated and sent around a 29 megabyte simplified model. So the data sender is happy because previously he was getting asked to simplify this model, but he's now saved hours of simplification time. He's also confident in the fact that he's only shared the tie-in details and the key features needed by the plant designer. So he's protected his IP. The consumers of the data downstream, it's perfect. That's exactly what they needed. It's an outer envelope, a simplified model. They can put it into their digital mock-up and it has the key reference points and tie-in points. It's also easy to place in their plant design system. They don't have to, it doesn't bring the system down, it doesn't cause a hang, it comes in quickly. It comes in first time. They don't have to iterate several times with different formats, try and fix it, iterate on that model. And the field receiver is just straight away. You can bring down 20 or 30 megabyte much quicker than you can 800 megabytes. So he sees that as a fast response. And likewise, the maintenance team are going to like working with that rather than the original 800 megabyte fully featured file. So there's some of the things that you can realize through doing a data simplification. And in terms of the process savings and benefits, you simplify the model, you reduce the file size. And in a lot of the companies we've worked with, that's the magic ingredient. I just want the file size smaller, they say. So you can significantly reduce the file size by simplification. If you simplify it right, make the file more manageable, you can eliminate the input failures into your plant design system. And in doing so, you eliminate the repeated iterations at trying to get the file in different formats. We've often heard the expression, I can't read the model, there's this squashed bug in the middle of it. This refers to the edges, the lines that define a very detailed piece of equipment that just sit in the middle of a plant design model, and you can't make sense of it. It's just too detailed. It's a bird's nest of lines, or squashed bug, as we refer to it here. There's also the potential for model deviation. If you try and read a model in and it doesn't come in, somebody might try and remodel it themselves. Well, you could get design deviation and things positioned correctly if they do that. The simpler model, the smaller model, should give you a greater stability in your process plant system as these large equipment models are integrated. Hopefully that would also eliminate system hangs that we've seen quite a lot. And ultimately, it will just reduce your lead times and give you a faster response as new pieces of equipment are delivered and need to be integrated into the plant design system. So that was a bit on the background of why you need to do it and the benefits that can be realized when you do it. What we've found is with our CADFix solution, we've got a lot of the tools available to help you simplify those models. I'm just going to look at some of those now. So CADFix is a well-established piece of software for CAD translation, repair and simplification. We have multi-CAD import and export formats, there's advanced repair and simplification tools, and the whole, I guess, rationale of using CADFix is it minimizes the rework and reduces the lead times as you take models between different CAD, CAM and CAE systems. And it's well established around the world in multiple industry sectors. And what we've found is a lot of the functionality we have for the general data exchange also applies to the process plant models and shipbuilding models. For example, quickly removing small parts, nuts, bolts, washers. You clearly don't need those in the plant system. Where there's a piece of equipment you want to keep but simplify, we can remove features. So take out holes, protrusions, the text for logos and fillets and blends that appear to simplify that piece of equipment. You could have a large engine, a large generator full of all of the internal mechanical parts. You just don't want to see them because they're unnecessary data to translate and to represent in the plant design system. You just want the outer envelope of it. And then there'll be other parts that are fairly complex structures that could be represented by basic primitives like cylinders, cones, spheres, prisms. So we've got tools to do that. And we've found that this large range of tools we've got in the CADFix product can be applied to the process industry. So just looking at some of them here, we can quickly and automatically identify and remove small parts based on size. So go into a model and just say remove everything less than a 50mm bounding box or 100mm bounding box. Highlight them, remove them, a one-step process. You could also automatically select parts of a similar shape. So rather than basing it on the size, you could select a particular component and say now find everything else that looks like this and delete it. Taking away excess detail. So here's an example of a small ball valve assembly where the original on the left has got lots of lettering, text, it's got small fillets, it's got holes, chamfers, and then on the right We've got a simplified version when it's been automatically removed. And in fact, we could go a lot further than this. This model could potentially be reduced to a cylinder with maybe a small prism on top to represent the handle. Depends on the level of detail that you need. But this is typical of the kind of thing we can do where you have some equipment you want to keep, but you need to simplify the definition. Removing holes has a significant saving on plant design systems. Every pipe has got an internal diameter. That's got CAD faces and surfaces to define it. On here you can see flanges at the end of the pipe that have got a large number of bolt holes. Just running a quick check to look for these and remove them can save 50% of the data in a pipe network almost, because you're removing half of the surfaces. And if you multiply that across an entire plant where you've got thousands of pipes, just a simple operation like removing holes could have a significant impact on the size of the model. I've already mentioned internal part removal. Here's an example of somebody's delivered a piece of equipment in the form of a small building, a small office, a small building. It could be a container which has got an HVAC system or a generator system or a motor system inside. You don't need any of that internal detail. You just want the positioning points for that building to go inside the plant. So with the CAD fix process, we can very quickly identify everything inside and delete it. So you're only exporting the outer shell. And then another thing is where you want to keep some equipment. So here's a motor and an attachment to it here. You may only want a simplified geometric form. You may want it converted into a cylinder or a box or a prism. So we've got algorithms and tests that will let you find these things that can be converted and convert them. Now that's lots of manual tools. Okay, manual or semi-automatic, you've got control, but it finds it automatically for you. We've also put together an automation wizard, a simplification wizard, that's an advanced complex process that will look at an assembly and identify things that can be deleted, holes that can be closed, solids that can be simplified, to go from an original complex form to a simplified form fully automatically. And yet we provide user options and control, so you decide the level of detail you want. And if there's a particular part you don't want to change, then we allow you to say keep this piece of geometry. So I've highlighted there a few of the things that we can do to apply to geometry to simplify it. Now I'm assuming that people on the call have to do a lot of these things themselves to simplify their models. So it's probably another good point to do a poll question on the level of simplification and how much time you have to spend doing this.
Yeah, let's ask that question to our audience. So everyone, let's ring in here kind of quickly. How much time do you spend simplifying your average equipment assembly? Maybe it's not a problem for you, maybe you're just learning today, but let us know if you're spending less than an hour, 1 to 3 hours, or maybe more than a day on these average equipment assemblies that can be kind of hairy sometimes. Give everybody a few more seconds to vote, and then we're going to close the poll and share the results. Let everybody know where they are in relation to their peers. We have a good audience size on today too, so this will be interesting. Okay, I'm going to close the poll. Here we go. So of the audience, 40% is spending 1 to 3 hours simplifying. 36% are spending more than a day. 16% less than an hour, 8% not a problem. So I am glad you guys are on the line. Hopefully you find some solutions here that can help you. Okay, Andy, I'm going to send it back to you.
Okay, thanks. Well, it's an interesting result. I guess you're on the call because you've suffered these kind of problems and want a solution, but it's good to know we're tackling the right area where you see these issues. If I just carry on with this now. So we've taken this established CAD fix product and we've applied it to the problems faced by the process and plant engineers. We've customized the interface, we've simplified the interface, and we've targeted it at simplifying large CAD models of equipment installations. And you've got the automation wizard supported by some manual simplification tools as a backup. So I'm just going to come out of presentation mode now, and I'll give you a live demonstration, probably about a 10-minute demonstration. I've got CADFix loaded on my laptop, so I'm now just going to bring in, I've got to process fairly small models because some of these things might take 5 or 10 minutes to run through, and we haven't got time to do that. So I've selected 3 or 4 models. The first one here is an ASYS SAT file, a SAT file. It's only 2.6 megabytes, an engine blower assembly. But it's a small model, but it's a good example of some of the simplification you can do interactively with a model. So this model, if you look on the bottom right-hand side of the screen, it's got consists of 36 solids. So there's several components in here, and I'm guessing you don't want these bolts, you don't want the holes, you may not want half of this structure. So I'm just going to do a few things of simplification, removing small bodies first of all. Now I could just accept this default tolerance and remove every body less than 100. I know now it's going to do some damage, so I'll do it, then I'll undo the process. It's deleted way too much. Okay, so I'll undo that. If I'd have measured the model first, I can just go end to end. You see the model is only 153 millimeters across, so this is a very small, either the units are wrong or it's a very small component. You could play around with the size of entities delete. You could say, look, I know this is a big model, anything less than 100, always delete it. Or you could pick on the model. So here I'm just going to select one of these small bolts. It gives me a size, and then when I say apply, all of those yellow bolts will be deleted. So they've all gone. Quick process to delete the small parts. Now you can see there's these holes. We don't want these holes. So I'm going to go through and remove holes in the model. I'm going to look for anything less than 10 millimeter and just say apply, and you'll see these holes disappear. Okay, they've quickly gone. Actually, I don't want this hole either. So what I'm going to do now is turn off the size check and just say apply, and those holes have gone. It's already starting to look a lot simpler. This vent on the blower, these holes in the frame, I don't actually want those either because they don't give me anything. So I'm now going to say any profile, apply. Again, simplified the model significantly. These cooling fins on the top I don't want, so one of the things we can do is convert it to a box. So I'm just going to select that solid and do a box simplification. Okay, we've now got a box on top to represent that. This model has got some internal components. If I just use the driver clipping plane through, you can see here it's got an internal crankshaft, piston, comrod. So what I'm going to do now is run an internal detail removal, apply. Let's remove the piston head and the conrod. The crankshaft is still there. The reason it's still there is because it's not internal. You can see it. But if we wanted to, we could just click on it and delete it. So I did some very quick simplification on that, and I'm now going to write it out to another ASYS SAT file. Okay, that's gone out. And if I just look at the file browser, we'll see the original file was a 2.6 megabyte SAT file, and this one is just over 1 megabyte. So it's a small model. There's not a lot of simplification you can do with that, but I got it down by 50%. So let's look at something bigger. This is an access ladder structure. Now the original step file is 79.6 megabytes, which I'm not going to read in. I've already read it into CADFix, and I've got the CADFix database, so I'm just going to open that. This is a fairly common structure for integration in a plant. There's lots of steel work. It's on its side because of the orientation, but I'll leave it like that because there's more on screen to see. If I zoom in on this junction, you can see there's lots of small bolts, nuts and bolts. They're small bodies. I could just say small bodies, delete everything less than 100, apply, and they've been deleted. I'll undo that. I could, small bodies, pick one, say OK, and apply. Deletes everything that's a similar shape. Maybe these metal plates between the struts aren't needed, so I could quickly pick one of them, say OK, and apply. They've all gone. There's lots of holes where the bolts have been removed, so I'm going to go into the hole removal. I'm not going to check the size, I'm just going to say apply, and it will delete all of the holes. Okay, so they're gone. If I shade the model in, I think straight away everybody who's watching will say, yeah, that's all very well and good, but the biggest problem here is that grating, is that floor panel, because there's so much detail there and we just don't need it. So what I'm going to do is, I'm just going to go back into wireframe mode. What I want to do is select those, they're individual solids. What I want to do is select them and put a box around them. But if I select them individually, it's going to take forever. So I'm going to say pick similar parts. If I select one of those solids, it's automatically identified everything else that's similar. These ones are shorter. Okay. I want to get the cross members as well. Zoom in and pick one of them. I think there's some ones that are slightly different that it didn't pick. So I've now identified everything, all of those solids that define the floor. There's an option here to say make one box around all selected parts and apply. So that's now creating a bounding box around all of those floor sections. And if I shade it in again, you see you've got a simpler form. If for some reason you thought these uprights want to be simplified to square sections, pick one, it picks all the similar parts, now I can simplify it. I could simplify the whole thing, I could put a box around the whole thing and say turn it into a prism if you want. But I'll just leave it at that now and I'll export it to a step file. So this is access ladder _CF for CADFix. So this is writing a new step file. The process is finished. And if I look in the file browser, the original step file was 79.6 meg. The one I've just written out is 2.1, 2.2. So pretty quickly we got a fairly massive reduction. I think most of that was achieved deleting the small nuts and bolts, which are just not needed. There's another way we can do this. I'll just open up another fairly complex assembly structure. Again, this was an 80 megabyte step file, but for speed I've already imported the into CADFix. You don't actually have to look at the model. You could just do it from an assembly tree. And in this case, this model has got an assembly structure associated with it. So this, you can just see the model that's come in. If I go to the assembly tree, we see on the left-hand side we've got this large assembly. And there's lots of components. There's hex bolt and hex nut. Now, without even going into the model, I could, by label, say, find everything that's star, bolt, star. That's highlighted everything in the assembly tree that's got a bolt on its label. It's highlighted on the model, and then I could quickly delete them. Okay, and I could do the same while it updates the screen. I could do the same for star, nut, star. Or I could have just used the word hex to find everything with a hex, or I could have put ISO or BSI. And if I delete those, now I could, I mean, this has made a big difference to the model already. It's deleted a few hundred solids. I could go and convert these floor gratings into blocks, but what I'm going to do for the sake of a demo is highlight them on the assembly tree and just say delete, because I don't want them in this case. So now the model has been significantly simplified. Maybe I don't want the holes, so I'll just do some hole removal, remove holes, and it'll get rid of the bolt holes and the internal diameters. And if I now go out to a new step file, and look at this in the file browser, there's the original step, 79.9 megabytes, and here's the one I've just written, 4.1 megabytes. So again, a big change. That was really to give you an idea of some of the interactive tools and the fact that you can still use them to simplify things quickly. But now I'm going to show you the automatic tool. So this is a step file of a pump that's 6 megabytes, a small pump assembly. I think I used it on a slide earlier. So there's 9 solids in here. The motor's one solid, this block's a solid, we've got some nuts and bolts. I'm not going to change any settings, I'm just going to go auto simplification, apply. This is now running a fairly advanced process to look for cylindrical parts that can be simplified to cylinders, parts that can be simplified to prisms or rectangular blocks. It's going to delete small entities, trying to make it a more manageable model. Okay. Now this is either something that you recognize and you want, this level of simplification, or you're horrified and you say, no, that's really changed the model, that's done too much. But it's retained the key points such that the feet with the holes in that contacted the floor, you've got the same base level, you've got the cylindrical structure for the motor, and then you've got a bound-in box and some bound-in cylinders for the other components. And if I undo that, we have an undo function, and compare it to the original, you can see actually that's a very good representation. Maybe you don't want to simplify everything. So one thing, there's a small pipe section here. Maybe that pipe is needed because you're connecting to something, so we want to keep it. So I'm going to add it to my keep list, and I'm going to run the simplification again. So this is now going through the same process, but it's going to retain that small pipe section and those connectors that I've left. So I think it only takes about 30 seconds with this model, but when you're running it live, it seems like it's forever. There you go. So now I've run the same automatic simplification process, but we've retained that small feature there. And I think that's probably all I want to do with this model, but if I put this out to a new step file, okay, and then look in the file browser, there's the original step file was 5.9 megabyte, this one is now 2K. So I hope that was, I'm not going to show anything else. I mean, I could run CADfix all day on lots of examples. We've got lots of real examples, but they just take too long for a short webinar. In the presentation, I've got some more case studies, which are more realistic. So here's an example of a sub-assembly of some stairs and platforms where we went from a 72 megabyte SAT file to a 4.8 megabyte SAT file. The face count came down from 26,000 to 4,500, 93% data reduction in 20 minutes, and the big change there was simplifying these grating panels to rectangular prisms. Another example, going from 37 meg down to 3.7, a 90% reduction in 25 minutes of a large skid assembly, a large equipment assembly. Here's some equipment on a skid. This was one I showed on the schematics earlier of the process flow. This went from a 798 megabyte step file to a 29 megabyte step file. Over 3,000 solid bodies down to 589. Quite a massive change in 20 minutes automatic running with some manual completion. And then you might not have a lot of large pieces of equipment that could be simplified. You could just have a very extensive pipe network with lots of small pipe fittings. We achieved a data reduction of over 50% with this largely used vessels and pipe network by removing the internal pipe diameters, bolt holes on flanges. So 50% with fairly minimal change. If we try and put that in the context of a project, the whole enabling to get to commissioning and production faster by removing all this time, simplifying geometry, ultimately it should increase your profit margins across a range of projects by eliminating that labour. This is one typical example of a project where you've got an 18-month contract period, you've got 8 designers that are engaged, and they're spending 4 hours a week simplifying CAD models. So 2,300 hours over the duration of the project. if you put an assumed labour rate of $125 an hour, that's 288k of man-hour time spent simplifying models that you don't really need to be doing, or you don't want to be doing. We've taken a cautious view with CADFix. We're saying, okay, you might not eliminate it completely, you've still got to have somebody doing some simplification, but let's just take it down to one designer and he's spending 8 hours a week. So we cut it by a factor of 4, which I think is quite pessimistic. We could do a lot more than that. But over the same 18-month period, the hours that you're spending is now costing you 72,000. So we see, just on one example, a potential saving of over $200,000 on one 18-month project. But that's just the beginning, really, because there's the lost opportunity cost of having your designers tied up doing this model simplification when they could be doing value-added functions on the plant design itself. And then you've also got to consider the time to market savings if you've got more manageable models, in that you've got a faster response to your field engineers. You can put the models together quicker. You can respond to maintenance requests quicker, and ultimately either avoid penalties for program delays or get some kind of reward for coming to market and completing and commissioning earlier. So we believe that we've identified a clear requirement in the market, and that CADFix can be used to meet that requirement, and we believe that by applying it to your problems you can save days of non-productive work and increase your efficiency and get things to market and commission faster. So that's, feel free to contact us if you want to for more information. I think we're going to hold a quick Q&A session. We've got a couple of minutes at the end, Margot, for doing that.
We do. We already have some questions, and those of you send in your questions now. We'll go to about 10:45 and then we'll take off. First question, do I have to perform the simplification again after an update of the assembly geometry, or is there an automated possibility?
You can run it automatically in that the wizard process is automated. If you work from the assembly structure, we can capture changes that you make to that assembly structure and replay those. We are also working, it's not available now, but we are also working on a macro capability for CADFix that will enable you to capture a series of interactive geometry operations and then replay them on another model. So I guess I'm saying we can do some of it automatically today if you're working off the assembly tree, but some of the more complex manual processes we will be able to do in the future.
Great. Now, a couple people have asked about supported formats. I know JT has come up. There's a specific question about that. Someone just asked in general what we support. We can supply a list after. In general, I pretty much think we support everything, but do you want to comment on that first, Andy?
Yeah, we support most of the common mechanical CAD formats. So we support, CADFix can read native models, native CAD models from CATIA, NX, SolidWorks, Inventor, AutoCAD, and then we can also read, and Creo, and we can also read a lot of the collaboration formats, so STEP, IGES, SAT, JT, STL as well, although we don't see a lot of STL. So yeah, all of the major CAD formats and neutral.
So for the JT, to be clear, they asked, does it need to include the solid geometry XT or JT BREP, or can it be simply surfaces, tessellation, triangles? I guess sometimes you can import and export requirements, could be that it's solid geometry only.
Yeah, most of what I've been talking about today has been with processing solid geometry, so BREP geometry. We can import a JT file that contains the BREP and the tessellated representation. We have some capability for simplifying tessellated models, and I've actually had an example recently where I had a complete warehouse model where the customer wanted me to give that warehouse model was represented as JT. When it was read into the CAD system, it was an unmanageable model. It was hundreds of megabytes where every JT triangle was a CAD face. We did some reverse engineering work to read those faceted solids from JT and turn them into CAD solids that could then be simplified. It's not what I was presenting today, but it is something that we can do, processing faceted geometry into a simplified form.
Okay, very good. Can we keep picked holes in the auto simplification mode?
At the moment, with the option we've got is to keep complete solids. We actually had a request earlier this week from a customer to say, could we keep selected faces as well? So we're looking at doing that now. So it's not out of the box today, but it's something we're looking at.
Okay. Do we work with point clouds at all?
Actually, can I just get that last question?
Sure.
On the hole removal, with the automatic simplification, we do have a whole list of options which you can turn on and off. So you could turn off the hole removal and it won't touch any holes. And you also specify diameter. So in the automatic process, which one, if people are on the line, I think I've still got CADFix running, so I can just show you the options. Yeah, here we go. Auto simplification options. So here you could see the option to remove holes. It's turned on and there's a value. So we could say remove holes and specify a smaller value, or you could just turn it off altogether. But there's also control. These are the other control options for the automatic process.
Okay, great. So that actually would solve as is.
Yeah.
Okay, good. So let's see here. Does CADFix also repair surfaces? That was one question. That's a for sure yes. It has a wonderful geometry repair and healing function, but you can speak to that better than I can, Andy.
Yes, we do. I mean, what I've been showing here largely today was a subset of the CADFix functionality, because we've found that to go after the process plant market, where people are just really worried about the file size, they don't want to get too caught up with the detail of repairing CAD models. So we're looking at a simplified, streamlined interface. But the core CADFix product itself is a much more comprehensive system with full repair capability for surface models, solid models, where we can turn surface models into solids. We can do the handling of faceted models, reverse engineering. So the full product is much more extensive than what I've shown here.
Great. If someone selects NX as an input format, is it possible that the resulted simplified geometry will be in NX native format?
No, we do not have an NX native export at the moment. What we would do for NX is we would export to JT or to Parasolid.
Okay, very good. We did not hit the point clouds question. Sorry, we went back and forth there. Is there, I know that there's some talk about point clouds and simplification. Can you speak to that?
We have some functionality for point clouds. We can read point clouds in, we can apply tessellation to it. But we have got some reverse engineering tools as well to reverse engineer that tessellation into a regular CAD solid, but that is very, very dependent upon the quality of the point cloud, the quality of the resulting tessellation, and whether or not there are clearly identifiable feature lines in the CAD model.
Great.
So I would say point clouds is kind of one of the things we're researching on for the future.
Okay. One last question, and this relates back to the NX question. In the case of NX format as input and JT as output, is it possible to maintain attributes present in the original NX file?
Okay, the attributes that we support are the color, the layer, and the CAD label. So we can take those attributes through, run them through CADFix and put them out to the JT file. It may be that there are other custom attributes that you need to process from the original plant design system. We could look at, we do lots of customization for customers. If there is a process that you have that needs certain attributes or metadata, we could look at whether we can support that as well.
Very good. Good. Thank you guys for your time. If you have, I see a few more questions come in, we're going to wrap up. We will answer you offline. You be sure to contact us. Our information's here on the screen, or you can reply to my email when I send the materials out later today or in the morning. Andy, thank you for your time, and thank you all for joining us. Yeah. Take care.
Thank you. Bye.
Bye-bye.